Hey everyone, this is Kendall Mansukani, McKenna Hart, and Claire Hill, and we chose to talk about the superhero Thor for the Anatomy Project.
Hi, my name is McKenna, and I'll be giving our overview of our superhero that we chose. We chose to do Thor. He is from the Marvel Universe. He is the son of Odin, the god of thunder, and he is the prince of his planet Asgard. We chose him for several reasons. One, because he's easily relatable as far as being human with just a smidge more help. And two, which was the most attractive reason, is because he is played by Chris Hemsworth. And we are a group of gals. Thor has a few different aspects which make him qualify as this superhero. For one, he has superhuman strength, speed, agility, durability, and immunity to several types of diseases. Throughout our presentation, we will be exploring the normal anatomy of humans, the super anatomy of a hero like Thor, and any weaknesses that he may have, be prone to, or be exposed to.
Okay, my name is Claire Hill, and I'm just going to be doing a quick overview of some normal anatomy and physiology concepts. So, of course, before we get into talking about everyone's favorite superhero and favorite actor, Chris Hemsworth, we are going to do a quick basic anatomy lesson. So the first topic we're going to get into is the red blood cells. So red blood cells are the most abundant cell found in the body, which points to their significance in the fact that they transport oxygen from our lungs to our body's tissues. The reason that there's the perfect cell for this role is because of their biconcave flat disc shape. So they have a small diameter, which is important considering they have to go through narrow blood vessels and different pathways to get to our body's tissues. And the composition of these cells is protein and iron. So iron is the element that's going to be binding to the oxygen, which allows hemoglobin to carry up to 4 oxygen molecules. So this is super efficient, considering we have millions of hemoglobin in our bodies carrying 4 oxygen at a time. And one way that we can increase our red blood cell count is through exercise, which is going to be talked about a little bit more later as we're looking specifically at Thor. So moving on from red blood cells, we have our skeletal muscle fibers. These muscle fibers span the length of our muscles, which makes a lot of sense given their name. The composition of these fibers are myofibrils, which are important for muscle contraction, which we'll talk about next. When our skeletal muscle fibers twitch, we classify those twitches into 2 different types. So first, type 1 would be our slow twitch, which is important when we're thinking about endurance. So I would think about cross country or long distance running. And then type 2 would be the fast twitch, which would be more like sprinting. So I think that's pretty easy to remember because sprinting, you're running faster usually than when you're doing endurance training. And that's our fast twitch. So that's pretty intuitive to think about. And then our last anatomy topic we're going to discuss is the myofibrils, which I just mentioned. These have an important function in specifically contracting the muscles through the sarcomeres. So our myofibrils are composed of thick and thin filaments. This thick filament is our myosin, and our thin filament is our actin. So this thick and thin filament composes the sarcomeres, and myofibrils have a striated appearance. So I like to think about striated as striped, kind of sounds similar, and it makes sense because it's referring to these light and dark sections on the myofibrils. So that splits up into the A band and the I band, and then there's different zones that connect to those areas more particularly. And then the most important thing to know really about the myofibrils is the sliding filament model, which is how we're going to conceptualize muscle contractions, which is through this mechanism of sliding filaments. So when we have a sliding filament model, our actin filaments are lengthening and our myosin filaments are shortening as myosin heads bind to actin filament. And they do this through ATP, so energy is required, specifically through glycogen. And the sliding of the filaments causes the muscle to contract, which is certainly important for Thor as he's constantly working on his physique. And lastly, fun fact about myofibrils are that shivering is produced by these muscle contractions. So I thought that was super interesting. And yeah, that concludes our basic anatomy lesson.
When exploring the anatomical differences of Thor versus a quote-unquote normal human, the first thing that we can see is muscles. Muscles equate to strength. So what is strength? Strength is built from exercising and creating trauma to the muscles, aka small tears, which then repair themselves. As with any repair, when you put glue on something or a Band-Aid, the more you put, the thicker it is, the stronger it becomes. It's the same thing with these tears in our myofibrils. The trauma of the muscles stimulates myofibrillar hypertrophy, also known as big muscles. Superheroes, as in the case of Thor, clearly have lots of large muscles. What could this be from? Their upbringings when they are forced to fight, train as youth, and their muscles are just stimulated in that growth pattern. Or even as their superhero adult selves, when they are out on the battlefields defending the planet of Asgard. Their muscles are being put to use constantly and daily. Another contributing factor to strength, which we'll explore later, is testosterone. Since Thor is a male, his body does indeed produce testosterone as one of his main sex hormones. Testosterone in and of itself can lead to more energy, thus allowing for more time and more efficient exercise. It also can be equated with larger muscle mass. But we will go into more detail with that in a couple of slides. The next major difference that we're going to explore is speed. Thor's speed is inhumanely fast, which is why he is a superhero. But what makes him fast? As we've all seen with sprinters when the Olympics are on or any track and field events, they are usually more muscular and bulkier. Most people would think that you want to be smaller and more lean in order to run faster. After all, the lighter you are, typically the faster you go. In the case of sprinting and speed, though, you want those big, bulky muscles. The reason being, they are full of what is called fast twitch muscle fibers. Fast twitch muscle fibers use less energy, meaning they do have shorter endurance, but they don't take as much from you. This also means they require more muscle power. That's why when you see these athletes with these large muscles, they are able to sprint so quickly because they do have the muscle power and muscle capability. I have to comment on the obvious, which comes from the speed and the muscles, which is his physique. He's built very well, and this helps keep him protected and allow him to be more agile, as his body is in great conditioned shape, allowing him to perform maneuvers that people who are completely out of shape, like myself, would not be able to do, and at least not be able to do safely or well. Now, looking at his durability, which also ties into him being in shape. Durability usually equates to endurance, which are run by the slow twitch skeletal muscle fibers. Those use more energy, but they last longer, and they don't require muscle mass to be successful. This is why people who go for long distances, i.e. long distance runners, are usually thin and lanky as opposed to the sprinters, which are much bulkier. And of course, we all know the heart-healthy effects of cardiovascular exercise on our system, i.e. the endurance training, the endurance running. Now to explore the endocrine system of somebody such as Thor. Our endocrine systems all function essentially the same way, producing very similar hormones in every one of us, with the exception being our biologically assigned sex and the sex hormones and the amount that we give. Since Thor is a male, the major sex hormone that he gets is testosterone. Testosterone affects all the things that make him him. Now, what that means is testosterone is responsible for helping males develop into men, boys develop into men, helps to form that masculine body. It helps to grow their facial hair, deepen the voice, and then it also contributes to their muscle strength. Muscles are not just for strength, they're also for speed, which we learned about a few slides ago. The stronger muscles, the more muscles, which is more fast twitch muscle fibers, thus creating more speed. The endocrine system is also responsible for EPO, or erythropoietin, which is the production of red blood cells. Since the planet of Asgard is a completely different planet, we can only assume that there is different atmospheric pressure there, thus giving Thor more endurance and more strength when he comes to Earth, as assuming it is lower than where he is originally from. That is to his benefit because nobody is checking his blood for levels of EPO or performance enhancing steroids. And finally, we need to talk about the immune system of Thor. All things have been super as it pertains to him, and this also includes his immunity. He doesn't get sick, things don't keep him down. It is listed as one of his strengths. He heals quickly, and Thor himself, being the god of thunder, is an electrical conduit. There was an interesting case study done by Tyler in 2017 talking about salamanders and how they are highly regenerative animals. They can create organ tissues, brain tissues, jaws, limbs, all of these things through a process called bioelectric phenomena. It's associated with their wound healing. If we apply this to Thor, who himself conducts electricity, it is no wonder why he isn't hurt, doesn't stay hurt, limbs stay fine regardless of the intensity of the battle that he is in. However, we do see that he is not immune from things such as human temptations and human indulgences, as pictured on the slide below. But who can blame him? Some of the best things that make us human are those sweet treats.
Hey guys, I am Kendall Mansukani, and I'm going to be talking about Thor's weaknesses or his potential weaknesses and how his anatomical physiology and the differences in his makeup might be negatively affecting him. So, as we went over earlier, the superpowers that Thor has include, but are not limited to, superhuman strength, superhuman speed. He's very agile, he has good durability, and he also has immunity to a lot of diseases. So a lot of people might actually argue that these powers are seen as pretty beneficial and healthy, if anything. So they may say that he does not have weaknesses from these differences and that he just sort of has more of a elite makeup for his genetics, because he does have strong immunity. He is not going to get sick as easily and can fight off bacterial and viral infections a lot better. And his hormone secretion seems to be quite healthy based on his muscle mass, which is very high. So we can assume that he does have a healthy amount of testosterone being secreted. And we can also assume that he has a healthy respiratory and cardiovascular system based on the amount of physical activity that he does perform, because he does need to be very active, and in all of his battles and fights he tends to be lifting heavy things, fighting off people, jumping, running, all sorts of that stuff, and he never seems to be too beat from it, which tells us that he is in shape, and that implies a healthy cardiovascular and respiratory system, which are obviously very beneficial for one's health. He also does not have any evidence of doing anything like smoking or anything of that sort, so we can assume that his lungs are healthy and he is doing well in that department. However, you could say that he does have some weaknesses, such as based on the amount of activity that he does do, he may have some overuse injuries, and these could be anything from muscular or bone or joint issues. Some things that it could happen are stress fractures, or a more minor version, a stress reaction, torn muscles, torn ligaments, or just joint problems. Just areas that are being used very often could potentially have problems. Another potential weakness that he has is his hormone imbalances. Because he does seem to have an excessive amount of testosterone, it could be implied that he has a low estrogen amount. And low estrogen can lead to delayed puberty and weaker bones, which could also allow him to get injured more easily with the overuse injuries. And Kaplowitz article, Delayed Puberty, which I cited in the resources, talks about this, saying that low estrogen can lead to a later puberty. But we can assume that with Thor, based on how old he is and how developed he is, that was not necessarily a problem for him. But it is uncertain whether or not he has weak bones. And these are our resources.